Hello, my name is Michael Nolan. Today we're going to talk about first steps for improvement, lead time reduction. The outline of the program is key measures of lean. In that we're going to look at what gets measured gets done and the need to gather data. Then we're going to look at batch versus continuous process. Batch is a traditional style of manufacturing. Continuous process is a lean approach. Process flow. We're going to look at a system of mapping out process flow and the tools for mapping it out. What's added value, what is not. And then finally, we're going to look at lean office. Lean business is not just about manufacturing, it's about the total business. So, key measures of lean. One key measure is time. And don't forget, time is a strategic weapon. It can be used to help increase the flexibility of the business so you respond more fast. And this is very important. If you can do that, customers need less stock, therefore their cash flow improves. And this can give you a strategic advantage. Another key measure is added value. This is where you're increasing the value to the customer without increasing the price. Again, it gives you an edge over the competition. Very important. Lead time reduction tackles both. So it tackles both the added value and the time and builds on that, so that you have a very flexible organization which can improve significantly. Finally, small steps make a difference. So take small steps. With larger companies, they often take a big approach and have many consultants in, looking over all their processes, and then have what we call a big bang approach. Everything happens together. So with the smaller companies, we say, take little steps, continuous little steps of improvement, and it'll make a difference over time. An example of small steps, the Inland Revenue in the UK. They used to have a process that opened up the post at noon, midday. And what happened then was the checks that were paid to them were taken out, brought to the relevant offices, processed, then the next day they were sent to the bank. When they examined the process in detail, they realized that they were losing a day's interest most days, but at weekends they were losing 3 days' interest. So they stepped out the process and looked at it and said, this is how we can change to open the post earlier and to process it so that it's all processed in the same day and goes to the bank in the same day. And then as a result of that, their cash flow improved tremendously and they made big improvements overall. They did many other improvements, but that was just one small step and how it can make a big difference. Another key measure is batch sizes. The optimum level is a batch of 1, but very often companies feel, I'd love to do a batch of 1, but we can't really because our system is so complicated, changeover times are so long, we can't do it, so we make 50, 100 at a time. And the trouble is, if you're missing one component for that batch of 50 that's needed in all 50 machines, it can't be finished until you have that component. So if you have only one, it makes a big, big difference. Difficult to do, difficult to get to, but it can be done. And it results in a flexible manufacturing business that can respond to customer demands more quickly, more accurately, and make huge differences. And they can be done with minimum delays. This leads to more responsive to customer demands, so that as the customer's demands change, you can be flexible and change with those demands. So that if suddenly they want something tomorrow, you set aside what you're doing now, and then you say, well, we make this quickly, and you get it out. You're responding to their immediate needs, and they're very happy with that. Then you can go back to the other one very quickly. You can only do this with quick changeover times, and that's one of the issues with it. But if you can manage the quick changeover times, it's a great system. Minimizes stock and finished work in progress. What we mean by that is, if you have small batches in a batch of one, then you have very little stock hanging around the factory, and you need very little finished stock, if any. The ideal situation, difficult to achieve, but the ideal situation is you have product that you make for immediate customer needs, which are delivered immediately, and you don't keep finished stock. Some companies can achieve that, but you try and get it as near to zero as you can in terms of finished stock. The more stock you have, the more money is tied up in it. So you're constantly trying to battle with that and to make sure that stock is kept to a minimum level. Otherwise, you need more money and complications like that, and they all affect profitability. The next one then is batch process versus continuous process. This is traditional versus more recent new. Example. We're going to go through an example here of a batch process and a continuous lean process, and to show you in a very small scale, in a very simple way, how the differences can look. So the first one is the batch. 3-step process for both of them, and then step 1, step 2, step 3. A batch size of 5, only 5 items, very small. The 5 items go through area 1, and they're processed 1 item per minute, so 5 minutes for the 5 items. Area 2, the same speed, 1 minute per item for 5 items, and you go through. Finally, area 3, it's the same speed, 1 minute per item, and 5 minutes it goes through. So that means overall 5 items completed in 15 minutes. Example of continuous flow. So what's the alternative to that? The optimum size of 1 item per batch. So it's a batch of 1, and you have 5 batches because of that. So the batch of 1, using the same criteria, 3-step process, 1 minute for each item. And then it goes, after 3 minutes, the first item is finished. And then after 7 minutes, the 5 items are finished. And the batch is completed, compared to 15 in the batch process. So it's a lot faster. Just to show this in graphic terms, if you look at the chart, you'll see batch process here on the left-hand side, and the 3 stages A, B, and C. B1 is for batch 1. And then on the right-hand side, continuous processes, A, then B, and then C, and it has a batch of 1. Each process takes a minute per item. So in each of the batches, for the batch process, 5 minutes, for continuous process, 1 minute. So let's look at those going through. On the left-hand side, the batch process, B1 is finished. It goes on to B2, it's finished, and B3. So in 5, 10, 15 minutes, it's finished. But we can also see that B2 has started in process A and has gone to process B. B3 has started in process A. So there's 15 items work in progress. Now, on the continuous process on the right-hand side then, we're talking single minutes here as opposed to jumps of 5 minutes at a time. And here we have batch 1, it's in A, it's processed, goes on to batch one in B, and then goes on to C. So in 3 minutes, the first item is finished. 4 minutes, the second item is finished. And it keeps going on until 7 minutes later, the fifth item is finished. So how much work in progress is there? If we look at lines 6 and 7, we'll see B6 is in A process and in B process in line 7. And then B7 is there as well. So we've got 3 items of work in progress compared to, on the left-hand side, 15 items. The learning points from this. Making batches small increases flexibility. And the reason for that is that with small batches, you don't have huge work in progress. If you're doing small batches, you have obviously overcome changeover times on production machinery, so therefore your flexibility is fantastic and you can meet customer demands and changes of demands very quickly. That's where the flexibility comes in. So from a flexibility point of view, it is absolutely fantastic. If problems are found, there are less defective items. If, for example, at the end of the batch of 5, you have 15 items of work in progress, and you've noticed that there's a mistake of what's finished, you then have to go through the 15 items that are half built and seeing if the mistake is in there too. Whereas with the other side, if one mistake is noticed at the end, you stop everything, and at most there'll be 3 items there, that's all. So you have 3 items to look at. On continuous flow, on batch, you have 15 items. So overall, you have to say that the continuous flow is a lot more flexible in many different ways. So as a result of that, less work in progress is needed, less finished stock is needed, if any, and that goes back to my point that you can make for manufacture if the process is quick enough. And then needs quick changeover if machinery needs to be adjusted. And that's a very valid comment, and it means it gives you that flexibility when you get the changeover right. Process flow. The purpose of this tool is it shows what's happening in a visual way. So it's used to map the process. You're looking at a map and you're deciding, where am I? You can see how the process develops. I suppose it's a bit like when you're looking at the start of this, it's like looking at a map. Where do I want to go? Well, before you answer that, you say, where am I? And then look at where you want to go. It helps identify value-added elements. In this business of process flow, improvement activity, whether it be in a factory, whether it be in an office, or wherever, there is a system, a process there. Some of that system is added value, some is not so much added value. The Japanese talk about 6 items being added value, about 10 items being semi-added value, and about 40 items being non-added value. So therefore you get an idea of the relationship there. There's a lot of non-added value for every little added value. So you're looking at what's making an improvement from the customer point of view and seeing how can I make improvements there. It helps understand current problems. Problems are more clearly identified, they can be seen more readily. It enhances communication of issues so that it's understood where you are with that. You're looking at waste, you're looking at minimizing waste. So how do you try and minimize that waste? What methods are you going to use? So you start looking at what's adding value, what's not. And then you're saying, well, the ones that are not adding value, how can I work those out of the system? What can I do that will make a difference? And therefore you're saying, yes, added value is good, non-added value is not so good. Assist moving towards future state. In this, you're looking at the waste and you're trying to eliminate it, first of all. And if you can't eliminate it, you're trying to minimize it. So it might be as simple as walking from one station to another to deliver product and trying to eliminate that. And maybe you can't eliminate it altogether, but maybe you can automate the process so that it happens smoothly without a person being involved. And that sort of activity helps to bring out the improvements and to take away or reduce down the amount of waste elements in this process. Tips on process mapping. Go and see what's happening. What we mean by that is go to the office area or go to the factory floor, whichever it is, and observe what's happening. But not only that, you need to be talking to people about what is happening there, asking people's views. What do you see as the problem? Where can we improve? And looking at it in that way. So you have to listen to staff and to their views. What I find is that in the work I do, when you're talking to people on the shop floor or in the office where the work is being done, they know a lot more of the detail of what's happening. And so therefore, by talking to them, you're drawing out a lot more information than, say, reading a report. Reading a report is not the same at all. So you need to look at that in great detail and say, ask questions about why is this happening, what's happening, where is it going to, why are you doing it this way, why are you doing it that way, and probing all the time. The Japanese talk about the 5 whys in terms of a process of gathering information. That's a very useful tool. By just asking, why are you doing it that way? I'm doing it that way because it's the way we're always told to do it. But why do it that way? Is there a better way to do it? And so on. You're probing all the time. Do flowchart at appropriate level. What we mean by that is there's a sort of a higher level appropriateness and then there's a lower level of great detail. Overview, great detail. So you need to be looking at those and saying, how can I make a difference here? How can I pull this through? And you're then saying, okay, which is the appropriate level, high level or low level? And that's what that's talking about. In essence, you'll probably do both. You'll start off with a high level and get an overview, and then you'll go into the detail. Okay, and the next part is teamwork is essential in developing process map. And that's getting back to asking individuals in the area questions, but also developing a team looking at this and throwing ideas at each other and brainstorming and finding ways to make improvements so that it improves dramatically and quickly and can then be developed fully and maximize the amount of value-added elements and minimize the amount of non-value-added elements. The next one then is process map should be used on an ongoing basis. We talk about continuous improvement. It's not just making an improvement and walking away, because what will happen then is you'll go back a little bit. If you've looked at the innovation lesson, it talks about the steps, and then if you're not working on those steps, you'll go back down. It's the same here on this process improvement. You have to keep working at it. So you do it now, you might go back to it next year and see if it's relevant. It might be 2 years' time, it might be 6 months, it depends. If a lot of changes have taken place, it's worth looking at again. Map out current state first. What we mean by that is what's happening now. That's what we're trying to find out. What is there? What are the steps involved? And depending on whether it's a high level or low level will depend on the detail. So it might be quite low detail at the high level, but when you get down to the low level, there'll be a lot greater detail. So you go into it in much, much more detail. And as I said, it's a bit like the navigation part, where do I start from? You start from your current state. You start from Roma or wherever you are. And wherever it is, you're going from there. Until you know where you're going from, you don't know where you're going to. So the current state is the first stage of the process. Identify the elements that add value. So in this, we're looking at what does the customer value and what would they like to keep in your process? And then you're looking at, well, what wouldn't they like to keep and how can we get rid of that or how can we reduce that? So that's where you start by identifying the elements of adding value. Use added value elements to develop an ideal state, ignoring the problems. So what we're saying there is you have your current state and then we say utopia, what's that like? The ideal state. If there was no problems at all, this is what it would look like. So you start off of the second part of the process of identifying the ideal state. So just the added value elements, ones that might be semi-added value, you leave out, just the added value. And what does that look like? It's important to get that picture of the ideal state because that's where you're going to be aiming for all the time in terms of looking at this perfect position to be in. So, ignoring those problems, that's the ideal state. Then you develop what you might call a compromise, but is the future state of process within current improvement activity. So within your current activity of improvement, how much of a difference can you make to that process? How many steps of the process can you take out? And very often, when people are looking at this, they take a very simplistic view of how many steps. Oh, in my company, when we make products, there's only 5 steps. You make it, you cut it, you pull it together, assembly, that's all. When you look at it, there might be 45, 48 steps, and 30 of those might be waste. So you have a lot more possibilities with 45, 48 steps as opposed to 5. And you can work with those and try and say, well, what can we do to improve these 30 odd elements of waste? You may not be able to get rid of them all, but if you've even got rid of a third or half of them, it would be a significant improvement on the current state. So that's what you're doing with the future state. You're trying to get it as good as you can at the moment. There might be other reasons why you can't get it any better at this time, but that's as good as it gets at this point. So you go from current to ideal to the future, and the future one is the compromise of the whole activity. Lean Office. What's involved in that? Well, I talked earlier about Lean being not just about manufacturing, that its offices, its systems, its marketing, it could be many areas, purchasing. In the office, it's equally important to be looking at Lean and how can we make improvements in there. So, how can we use Lean in the office? And we often, as I said, concentrate on the manufacturing in that and forget that it should be used in the office as well. Products are not made there. Yes, that is true, but processes are carried out there. And it's to improve the process of the accountancy system, the debtor system, the invoicing system. There are lots of systems in there you can improve, lots of processes you can improve. So it's a matter of tackling which ones you feel are maybe the weakest ones at the moment. For example, if you're having trouble getting money in from companies in terms of debtors, you might look at the debtor process, the whole credit control process, and what's involved in that, and come up with steps of making it better, faster, smoother, and getting cash in quicker, which would be the ultimate result of the improvement. So focusing in on that sort of activity, you can make huge improvements. And there's lessons to be learned there throughout the office in terms of that. There are many administration processes, order entry, accounts receivable being one, as I said. Purchases, accounts payable. The system you have for purchasing is very important. The number of suppliers you have, how good are they as suppliers to your business? Looking at that process can bring in huge benefits to the office, to the business as a whole. So you're striving to make improvements there. Production planning and the whole process of trying to plan what's needed. Again, lean coming in there can make huge differences. Again, it's an office environment on the planning side, but there are huge differences that can be made. And then finally, management accounts, etc. There's still improvements to be there, particularly with management information. I think that's one area, I know it's been discussed in other lessons, but it's an area where you need to focus on and say, what's important from that point of view? What information will help us to manage the business better? And then to work towards that and to draw out that information, gather it, and then say, right, well, this is what we need, and work back from that and say, how do we get that from the systems we have? How do we get management accounts information in that helps with those systems, and so on. So it works like that. Lean office example. They say it's often easier to map a theoretical optimum first, and that may be true, I don't know, but it's certainly worth talking about. We're going to take an example here, a theoretical order entry process. So this looks very straightforward. I'll just take the mouse here and we'll just go through them one by one. The first one is receive order. So the customer gives you an order. Enter into sales order record. Again, that's very straightforward. Then you have check account status. So what are you doing? Are the company paying you on time? Is there delays? Are the delays big? If they're big, you don't want to send out more product to them and they owe you even more money. So you check that. That's okay. So place order on production system. And then it goes to plan into production. So the production planners get a hold of it and work towards making it happen bit by bit. And then you produce the product, and then you ship the product out to the customer, and then you invoice the customer and ultimately get paid. Now, that's a theoretical one. In reality, what happens? Let's have a look. Actual order entry process, and the full order entry process isn't actually here. There'll be about 3 or 4 more steps in it, and this is done at a high level. It's not very detailed. 1, receive order, goes into reception. 2, it goes from reception to the sales office. 3, it waits there. It sits while someone has time to process it. 4, enter the order, enter the sales record. So it's recorded. 5, it goes to finance. And finance, it's not a high priority job. They've other work much more important. So 6, you wait. Again. 7, they look at it. The account is okay. So they clear the account that it can go forward. To 8, back to sales. And what do? They wait because they're doing more important work at this point. So then they get around to it, and 9, weight, 10, production planning. So it goes to production planning, and they say, oh, this is very good, but we're doing something else just at this point, so we'll wait, which is 11. And it goes through a process like that. It goes from there to production, 12, 13 is produce, 14 ship, 15 wait, and 16, 17, 18, it goes on. It's not a pretty process, there's probably a lot more waiting in there in reality as well. But you can see, you can get an idea from that. Lots of waiting, not much work in between. So how does that look graphically? Order entry process, paper flow. So it starts in the top left-hand side with the customer, and there, following the mouse again, it goes over to reception. It then goes down to sales with the little bit of waiting. Don't forget the waiting, it's there. It goes from sales over to finance, and again it waits. Eventually they get around to it, and it comes back from finance back to sales, and then it waits again. It goes from sales into production planning. Here's a little bit more detail on it. It goes from there to design and to purchasing, in terms of telling purchasing they'll need to get more raw materials in, and telling design there's some design work need to be done on this. They also send it to production, and design coordinates with that in production, goes to shipping, and then the customer receives the product. So again, this is a very high level, not much detail, but you can see there are lots of waiting involved here. So it's really important to make sure that you minimize this waiting as much as possible. Administration traditional. What do we mean by that? If you look at this, sort of the administration, the order comes in, and there's little, what I'll call silos, little groups, one group here, one group here, one group here. They're not talking to each other. You have administration are all together, finance are all together, planning are all together, production are all together, and shipping are all together. But they don't talk to each other very much. And if they do, it's from a distance, over the phone, over the email, or in written form. So it's very impersonal, there's no relationships built up, unless it's a very small company. And so therefore, you have these communication problems that are difficult to resolve and overcome. So, from that administration, world-class business, you have this sort of format where they're all interrelated. You work as a group together in terms of the administration, AG, and then F is finance, planning is PL, production is PR, sales. They're all working together, interrelated, and communicating directly with each other. So it's a much better process than the other, and much more likely to lead to good communications. Case study. International Meat Ingredients. That's the name of the company. They started business in 1993. They're employing 65 people, and on top of that, they're processing meat into added value products, some of which would be like salami type products. So it's quite a nice company. It's reasonably small, but not very small. The business administration process. So what was involved? Staff were basically snowed under with paperwork. Over time, the business had grown from very small to a medium-sized, a smallish medium-sized company. But it had grown gradually, and the complexity had grown gradually, so that people didn't notice the complexity growing. And as a result, they were snowed under with the amount of paperwork and documentation that was there. So what did they do? They mapped out the process in great detail, setting out every small step involved in the process. And what did they find in that? Well, there was a paper trail for an order coming through to it being shipped out. There was 42 pages of paper. What we actually got them to do was to, on a big wall, to put up every single piece of paper involved in the process. And it filled most of the wall, and the wall was quite large. On top of that, there were 3 systems used, 3 different computer systems. There was the marketing system, there was a financial system, and there was the production system. And yes, you are right, they did not talk to each other, which added to the complications of communication. So as a result, there was lots of re-entry of data, which is waste. Any data should only be entered once. If it's entered twice, 3 times, 4 times, it's waste. The first time is not, after that it is waste. So that was one of the problems they had there. They developed a new physical flow, they mapped out the process and said, okay, this is our future state, this is where we're going to work from now on. So what were the results of this? Changed the office staff to match the new flow so that they were changed around quite radically, and different people from different departments were pulled together in order to improve this communication. The results, quite startling. Paperwork was reduced by 50%. Yes, 50%. So that is a big improvement. So from 42 pages to 21. Still not fantastic, but it's a lot less. What else happened? Non-value added steps were reduced. They were halved as well, the non-added value steps. And it was a huge, significant improvement on how the company operated. And the final part was brain power freed to find new improvements. So what it meant was, having made those changes, they all found they had more time to make more improvements and more changes, so that there was a continuous improvement cycle. And all of that meant that it was a world-class company because of the improvements they made. Lean is very simple in structure, and some people can think it's a very simple process. It is on one level, but it's very difficult to implement properly. You have to work at it continuously and be adding value all the time and say, how can I make this better? And it's a matter, as I would have said in earlier lessons, of asking people to bring their brains into the factory as well as their bodies. People working with their hands have brains as well, so don't forget that. And try and encourage them to come in and involve them in processes like this to make improvements and to make differences to how we operate. And if you do that, you will see huge improvements in your company and you will become stronger. And process improvements like this, as I would have said in the innovation one, are hidden. Process like this, the opposition, your competitors cannot see them. So unlike product improvements, process improvements like this, they are hidden and they are undetectable. So thank you very much.